Stop just using AI and start mastering it. The AI revolution is here. We will take you past the headlines, diving into the core of basic AI concepts, understanding what makes a powerful LLM, how GPT works, the magic of NLP, and tracing the rapid evolution of generative AI itself. You need more than surface knowledge. It's not just a chat box unlocking the full utility of the world's most powerful tool. We give you a complete deep dive into ChatGPT Navigation, showcasing every hidden tool, tab, and function you never knew existed. Turn your account into professional workstation. But the real power is in the conversation. Forget the frustration of simple prompt that gets you generic results. This course transforms you into prompt engineer. We show you the exact structure difference that gets you precise, repeatable, high value output every single time. It's time for advanced strategy. Master the three pillars of AI reasoning effortlessly. Get complex results with cheap zero shot prompting. Use few shot to teach the AI by example and build multi-step logical solutions with chain of thought prompting techniques. We pull back the curtain of the AI's engine, gain total control by understanding the technical framework, learn how to manage the AI's creativity using temperature, its vocab with top P, and its focus with frequency penalties. These are the dials that turn good results into perfect results. No theory without practice. See it all come to life with clear, real world demo scenarios, solving complex tasks right before your eyes. And the best part, you get an entire pre built prompt library resource, instantly implement proven high converting prompts from day one. Call to action. Enroll in the
About prompt engineering science, we need to understand some basic AI related terms. Now, what is artificial intelligence? Artificial intelligence or AI is the science of building machines that can think, learn, and act like humans, at least in specific ways. Instead of being hard coded for every single task, AI systems are designed to analyze data, recognize patterns, and make decisions on their own. To understand how AI works, let's break it into key components. Everything starts with data, raw information like text, images, or numbers. Next come the algorithms, which are step by step rules to process the data. Then we have machine learning, where AI actually improves itself by recognizing patterns. And finally, neural networks. These mimic the human brain to solve complex problems like recognizing speech or images. Together, this flow from data to algorithms to learning and then to output forms the foundation of AI. AI is no longer just a futuristic concept, it's already transforming our daily lives. In healthcare, AI helps doctors diagnose disease faster and even supports drug discovery. In finance, it plays a big role in spotting fraud and predicting stock market trends. In education, AI is creating personalized learning experiences and even acting as virtual tutors. And in entertainment, from ChatGPT conversations to Netflix recommendations and smarter gaming, AI is everywhere, making our experiences smarter and more engaging. An LLM or large language model is a type of artificial intelligence designed to understand and generate human-like language. It's trained on massive amount of text, books, website articles, code so it can predict words, form sentences and hold conversations like we do. To understand how large language models works, let's break it down step by step. It all begins with training data, which includes billions of words from books, websites, and documents. This is where the model learns language patterns. Then we have neural networks, layers of algorithms designed to mimic how the human brain processes information. Next, the text is broken down into tokens, which are small unit like words or subwords. This helps the model handle language more efficiently. Finally, through prediction, the model learns to guess the next word in a sequence, and by repeating this process, it generates fluent and meaningful sentences. So, an LLM is essentially learning from vast data, processing it through networks, and predicting text step by step to produce human like responses. Large language models are powerful because of their wide range of applications. First, in conversational AI, they power chatbots and virtual assistants like ChatGPT or Bard that can handle customer queries or provide smart responses. Next is content creation. LLMs can generate blogs, emails, scripts, and even help summarize long documents, saving us both time and effort. Then we have coding assistants. Tools like GitHub Copilot use LLMs to suggest code, fix errors, and speed up programming tasks. And finally, knowledge and research. LLMs can answer complex questions, act as personal tutors, and even assist in scientific exploration. So, LLMs are not limited to one field, they are reshaping industries across communication, creativity, technology, and research.
Natural language processing (NLP) is a branch of artificial intelligence that teaches computers how to understand, interpret, and respond to human language, the way we speak and write.
Let's quickly see how natural language processing works step by step. It all begins with input text, raw human language in the form of written text or even speech. Next comes text processing, where the computer breaks down the sentences into words, grammar, and basic structures. Then we move to syntax and semantics, where the system tries to understand not just the structure but also the actual meaning of the words in context. This leads to the understanding phase where the machine interprets intent and context behind the words. Finally, we get the output response. This could be an answer from a chatbot, an action taken by a voice assistant, or even a translated sentence. So, NLP transforms human language into something machines can understand and respond to intelligently. Now let's look at how NLP is applied in our daily lives. First, we have chatbots and virtual assistants. These power customer service and smart Q&A systems, like when you chat with their website bot or ask Alexa a question. Next is translation and transcription. Tools like Google Translate or Live Captions use NLP to break language barriers and make communication easier. Then comes content recommendation, whether it's YouTube suggesting your next video or a search engine personalizing results. NLP helps tailor information to your interests. And finally, healthcare. NLP is used to analyze patient notes and medical reports, supporting doctors in making faster and more accurate decisions. So, NLP is already embedded in the systems we use every day, often without us even realizing it.
GPT stands for Generative Pre-trained Transformer. It's a type of large language model created to understand and generate human-like text.
GPT stands for Generative Pre-trained Transformer, and its name itself explains how it works. First, generative means it can create new content, sentences, answers, even ideas. Next, it is pre-trained on massive datasets like books, websites, and articles, so it already has a vast base of knowledge. Then comes the transformer architecture, which is designed to pay attention to context. This is what makes GPT understand the meaning of words in relation to one another. Finally, using the knowledge, GPT makes predictions. It guesses the next word in a sentence. By repeating this process, it builds meaningful and human-like responses. GPT is powerful because of its wide range of real life applications. It's used in chatbots and assistants like ChatGPT or customer service bots to provide instant human like responses. It supports content creation, generating blogs, marketing, copy, and social media posts quickly and efficiently. In the field of coding help, GPT assists developers by debugging, generating code, and even writing documentation. And finally, for learning and research, GPT can act as a tutor, simplifying complex topics and help summarize large amounts of information. This versatility is what makes GPT so impactful across industries.
Generative AI marks a major shift from traditional AI. While earlier systems focused on prediction and classification, GenAI unlocks creativity by generating entirely new context, whether it's text, images, or code. Its strength lies in novelty, diversity, and contextual understanding, allowing it to produce outputs that are both original and relevant. The recent boom in Gen AI is fueled by access to massive datasets, making this technology more powerful and accessible than ever before. This slide provides a foundational understanding of large language models, which are at the heart of generative AI. LLMs are sophisticated neural networks trained on vast amounts of textual data, ranging from books and articles to web pages. Their primary function is to predict the next word in sequence, but this seemingly simple task enables them to generate coherent, contextually rich, and human text across a wide variety of domains. The side highlights how LLMs works and what makes them powerful. First, they possess contextual understanding, meaning they can interpret the intent and nuances behind a user's prompt. This allows them to respond in ways that are not only grammatically correct but also contextually appropriate. Second, they excel at text generation, which includes tasks like writing emails, composing articles, summarizing lengthy documents, and even translating languages. Some of the best, most well known examples of LLMs include GPT-3, GPT-4, and GPT-5 by OpenAI, which power ChatGPT. Bard, now Gemini by Google, and Llama by Meta. These models have revolutionized how we interact with machines, making it possible to have natural conversations, automate content creation, and enhance productivity across industries. In essence, LLMs are not just tools for generating text, they are engines of understanding and creativity. Their ability to learn from massive data sets and produce meaningful output is what makes them central to the Gen AI revolution. So, continuing from the previous slide on large language models, this slide showcases how those powerful models are being applied across industries to drive real world impact. In content creation, LLMs are used to generate marketing copy, scripts, and social media posts, helping brands maintain consistency and creativity at scale. Moving to customer service, these models power intelligent chatbots and virtual assistants that can handle queries, resolve issues, and provide personalized support 24/7. In the education sector, GenAI enables personalized learning experiences by creating tailored study materials and offering tutoring support based on individual needs. This helps educators scale their efforts and reach diverse learners more effectively. Finally, in software development, LLMs assist developers by auto-completing code, identifying bugs, and generating documentation. This not only speeds up development cycles but also improves code quality and team productivity. Together, these examples illustrates how Gen AI is not just a technological breakthrough, it's a versatile tool reshaping workflows and unlocking new possibilities across domains. This slide shifts focus to another powerful branch of generative AI, that is diffusion models, which go beyond text to generate visual content. These models work by starting with random noise and gradually refining it into a meaningful image guided by a text prompt. It's like turning static on a TV into a detailed picture. During training, they learn how to add noise to images, and during generation, they reverse that process to create stunning visuals. Popular examples include Midjourney, Stable Diffusion, and DALL-E, which are known for producing high quality, detailed, and artistic outputs. These models are especially effective in capturing textures, styles, and fine details, making them ideal for creative tasks like art design and visual storytelling. Building on diffusion models, this slide highlights their diverse applications, from generating photorealistic images and videos to creating 3D content and transferring artistic styles.
They are even being explored in medical imaging, showing how Gen AI is expanding far beyond text into powerful visual domains.
So the core of generative AI is revolutionary because it moves beyond classification to actively generate new content like text, code, or images that is original yet statistically consistent with the data it was trained on. This is the key shift. AI is moving from dissemination or passively identifying what already exists to active generation, creating novel data. The underlying operational principle for LLMs is fundamentally predicting the next word or token. The model does not understand content like a human. Instead, it uses its immense training to calculate the probability of what element should logically comes next in a sequence. As shown in the example, Matt is chosen because it is the statistically most probable token. This simply scaled up probability engine is what allow LLMs to produce coherent, creative, and complex outputs. This slide, titled The Underlying Architecture, the Transformer, explains the core innovation that powered the generative AI revolution, essential backbone of modern Gen AI. Before it, previous neural network architectures like recurrent neural networks struggled with the problem before processing very long sequences of text efficiently, often forgetting information from the start of a sentence as they reach the end. The solution was a radical shift from sequential processing to parallel processing. This was achieved through the attention mechanism, the architecture's crucial idea. When the model generates a new word, it does not read the preceding words one by one. Instead, it instantly calculates and weighs the importance of every other word in the input simultaneously. This specific feature, called self attention, allows the model to instantly grasp the relationship and context between words, even if they are far apart in a sentence. This parallel approach is what provides the necessary scalability for a model to train on massive datasets, trillions of tokens, and scale up to billions of parameters, leading to today's powerful LLMs. Training process breaks down the typical two-phase methodology used to create modern powerful large language models. Phase 1 is the pre-training, the foundation. This phase builds the model's core intelligence. It uses a massive diverse datasets like the entire digitized internet with the goal to learn fundamental language structure, grammar, context, and general world knowledge. The mechanism is unsupervised learning. The model is simply trained to predict a masked out word or the next word in a sequence. The output is the foundational LLM, which is brilliant but raw and unaligned. Phase 2 is the fine tuning and alignment, making it more useful. This phase refines the foundational model with the goal of making it helpful, safe, and good at following instructions. This requires supervised learning and human intervention utilizing two main techniques. First is the instruction tuning, training the model on thousands of high quality examples of conversational prompts and ideal responses. And in the second step, reinforcement learning from human feedback, that is, the humans rank different model outputs for the same prompt, and this feedback is used to further optimize and align the model's behavior to human values and expectation. So this two-step process transforms a basic production engine into a highly capable and functional AI assistant. So the core of generative AI is revolutionary because it moves beyond classification to actively generate new content like text, code, or images that is original yet statistically consistent with the data it was trained on. This is the key shift. AI is moving from dissemination or passively identifying what already exists to active generation, creating novel data. The underlying operational principle for LLMs is fundamentally predicting the next word or token. The model does not understand content like a human. Instead, it uses its immense training to calculate the probability of what element should logically comes next in a sequence. As shown in the example, Matt is chosen because it is the statistically most probable token. This simply scaled up probability engine is what allow LLMs to produce coherent, creative, and complex outputs. This slide, titled The Underlying Architecture, the Transformer, explains the core innovation that powered the generative AI revolution, essential backbone of modern Gen AI. Before it, previous neural network architectures like recurrent neural networks struggled with the problem before processing very long sequences of text efficiently, often forgetting information from the start of a sentence as they reach the end. The solution was a radical shift from sequential processing to parallel processing. This was achieved through the attention mechanism, the architecture's crucial idea. When the model generates a new word, it does not read the preceding words one by one. Instead, it instantly calculates and weighs the importance of every other word in the input simultaneously. This specific feature, called self attention, allows the model to instantly grasp the relationship and context between words, even if they are far apart in a sentence. This parallel approach is what provides the necessary scalability for a model to train on massive datasets, trillions of tokens, and scale up to billions of parameters, leading to today's powerful LLMs. Training process breaks down the typical two-phase methodology used to create modern, powerful large language models. Phase 1 is the pre-training, the foundation. This phase builds the model's core intelligence. It uses a massive, diverse datasets like the entire digitized internet with the goal to learn fundamental language structure, grammar, context, and general world knowledge. The mechanism is unsupervised learning. The model is simply trained to predict a masked out word or the next word in a sequence. The output is the foundational LLM, which is brilliant but raw and unaligned. Phase 2 is the fine tuning and alignment, making it more useful. This phase refines the foundational model with the goal of making it helpful, safe, and good at following instructions. This requires supervised learning and human intervention utilizing two main techniques. First is the instruction tuning, training the model on thousands of high quality examples of conversational prompts and ideal responses. And in the second step, reinforcement learning from human feedback, that is, the humans rank different model outputs for the same prompt, and this feedback is used to further optimize and align the model's behavior to human values and expectation. So this two-step process transforms a basic production engine into a highly capable and functional AI assistant. So the harnessing the power of the training process we just reviewed. This slide illustrates the two most common and impactful applications of Gen AI: content creation and summarization. In content creation, the primary goal here is to massively accelerate the production of high quality targeted text. The underlying mechanism is the Gen AI model's ability to instantly understand and replicate a specific tone, audience, and document structure. The key benefit is a dramatic reduction in time to draft from hours down to minutes, shift human effort away from initial writing and towards crucial editing and strategic refinement. Second is the summarization, the reader. In contrast to creation, summarization's goal is to efficiently extract the most critical information from vast amounts of text. This is achieved using the advanced alignment techniques from the training process, specifically instruction tuning and reinforcement learning from human feedback. These techniques ensure the model acts as a highly effective reader, capable of filtering noise and isolating core facts to provide concise, accurate responses. Now, shifting our focus from natural language text, this slide highlights another crucial area where generative AI excels: code generation and explanation, positioning Gen AI as an indispensable tool in the software development lifecycle. So, Gen AI in software development. First is code generation, junior developer. The goal here is to help developers write, complete, and debug code across dozens of programming languages. The mechanism underpinning this capability is the training of models on billions of lines of public code. This massive exposure allows the AI to deeply understand not only syntax but also best practices and the logical structure of software. Its practical applications range from code completion to drafting complex multifunction blocks, significantly speeding up development time. Next is the code explanation and review bonus use case. GenAI also serves a vital function in reviewing and maintaining existing systems. This bonus use case involves the AI analyzing code written by humans or other systems to explain its purpose, helping new team members quickly onboard. Furthermore, it can proactively identify potential security flaws or suggest performance improvements, acting as an always on expert reviewer to enhance code quality and stability. So, bridging the gap between pure data and human understanding, this slide illustrates GenAI's critical role in data analysis and synthesis, transforming raw figures into actionable insights. So, GenAI's first key function is data analysis and interpretation, converting complex raw structured data like tablets, spreadsheets, or JSON into natural language insights. The mechanism involves the model processing the data directly or by intelligently generating code to perform calculations. The applications are vast, including automatically generating executive summaries from financial statements for reporting or helping researchers interpret scientific data and formulate hypotheses. The second core capability is the synthesis power, combining disparate pieces of information such as marketing data, customer reviews, and internal sales figures to create a unified, actionable report that human analysts can immediately use for decision making. Moving from model capability to practical usage, this slide introduces the critical discipline of prompt engineering and breaks down the structure required to unlock Gen AI's full potential. Anatomy of an effective prompt. Prompt engineering is defined as the discipline of designing and refining inputs prompts to guide large language models toward generating the desired accurate and high quality outputs. Effective prompts are not just questions, they are structured directives built around. There are four core components of effective prompt. First is the role, defines the AI's persona, instructing the model to act as a specific expert, example, a financial analyst, an engineer, a chef. So these can be the roles. So second is the instruction. Instruction is basically defining the task, specifying the main action the model must perform. And third one is the tone or the format, like defines the style and structure dictating how the output should look and sound. Example like professional report, a casual email. And fourth one is the output constraint, like you need to define the limit, setting boundaries for length, date, or explicit exclusions like keeping the summary under 150 words. So, combining these components moves prompting from guesswork to a precise science. Building upon the anatomy of a prompt, this slide introduces the foundational strategies used to structure the prompt itself, that is, distinguishing between zero shot and few shot prompting. In zero shot prompting technique, this is the simplest technique involving giving the model a task with no examples. It relies purely on the model's pre trained knowledge and is best suited for straightforward tasks, such as asking for a definition like define quantum computing or general information. The model uses its massive foundation training to generate the response directly. In few shot prompting technique, it harnesses the power of examples, like it involves providing 1 to 5 examples of the input output format before presenting the final query. In the example, like mapping a color name to its hex code, the model quickly learns the desired patterns
and structure. This technique significantly boosts performance and accuracy for complex patterned or subjective tasks as it effectively programs the model's short term context window. In chain of thought prompting, which unlocks complex reasoning capabilities in LLMs, the core concept is to explicitly ask the model to show its step by step reasoning before providing the final answer. This technique effectively mimics human internal thought process. The primary use case involves challenging tasks like complex mathematical problems, logical deductions, or multi step reasoning. The key instruction is a simple phrase such as think step by step, or first outline the logic, then provides the conclusion. The resulting benefit is profound. It forces the model to slow down its generation process, allowing it to allocate more computational steps to internal logic, dramatically improving the accuracy and robustness of answers on tasks that require critical thinking. As we refine our prompting skills, this final slide provides essential guidance on navigating the challenges of interacting with LLMs, highlighting common pitfalls and best practices for reliable output. There are three key pitfalls to avoid when designing prompts. First is vagueness, using generic terms like good or do better, which provides the model no clear direction. Second is ambiguity, asking a question with multiple valid interpretations which lead to unpredictable results. Third is over constraint, adding too many conflicting instructions in one single prompt which confuses the model. To counter these, effective best practices include being specific about the desired quality and depth, providing context and defining niche terms, breaking complex tasks into smaller sequential steps, mirroring chain of thought, telling the model what to do rather than what not to do. Example, use a casual tone, not don't sound formal.
Today's session, we will learn about most renowned AI tool, ChatGPT. By the end of video you will be able to understand ChatGPT's interface and navigation. Know what each tab and features does. See real-world applications of ChatGPT in different domains. Learn some pro tips for better results. ChatGPT is an AI conversational assistant by OpenAI, capable of answering questions, creating content, and assisting with work. There are various models available in free as well as paid category. ChatGPT 3.5 is the basic free version available for public. Rest others ChatGPT 4o, O4 Mini, O4 Mini High, O3 Mini, 4.1 Mini and 4.5 are in paid category. Now let's start with ChatGPT Navigation. First log in with ChatGPT official website, chatgpt.com. On the top left corner, there is a logo of ChatGPT. And close sidebar tab, from which you can open and close sidebar of ChatGPT. Now in the left sidebar, first tab is New Chat. By clicking this tab it will open the search or input prompt box. By entering the prompt, it will generate its response in the canvas by searching through wider networks or database. By clicking Search tab you can search any word, message, or file across your entire chat history instantly. Library is your centralized vault for every file, document, and knowledge resource shared in chat. The Library tab automatically captures every attachment, note, and link exchanged across your workspace, organizes them by type and conversation, and makes them searchable in a click. It's like having a smart filing clerk who never misplaces a thing. Codex is basically AI-powered coding assistant built into ChatGPT. Write, debug, and explain code across languages in real time. Whether you're prototyping, debugging, or learning to code, Codex in ChatGPT acts like an expert pair programmer, instantly generating code, fixing bugs, explaining logic, and even suggesting optimizations. It supports dozens of programming languages and integrates with your chat flow, so you can build software and solve technical problems without switching tabs or tools. With GitHub integration, ChatGPT becomes more than just a coding assistant, it becomes a live collaborator. By connecting to GitHub, users can pull in repository data, explore file structures, analyze commits, debug code, and even generate documentation. Sora is OpenAI's AI model that turns text into realistic, dynamic videos, bringing imagination to motion. Sora marks a revolutionary step in generative AI by transforming simple text prompts into high-fidelity, cinematic video clips. With just a sentence, users can generate complex, coherent scenes that blend motion, detail, and creativity. From surreal animations to real-world simulations, Sora brings stories to life, frame by frame, powered entirely by text. In the right side, you will be able to see your video download progress in the Activity tab. Sora is not just a text-to-video tool, it's a gateway to visual storytelling without cameras, sets, or actors. It's where imagination meets generation. Sora can generate these visuals with shocking realism, making it a tool not just for entertainment, but also for marketers, educators, filmmakers, and creative professionals looking to prototype or pitch ideas faster than ever. You can export or download these videos in your laptop or computer from the right side. The GPT tab is your personalized AI command center. Whether you're a developer, educator, marketer, or everyday user, this tab lets you create your own AI assistants, no coding required. You can explore pre-built GPTs from the community, clone and edit them, or build one from scratch using natural language. Each custom GPT can have unique instructions, files, API integrations, and even a personality. This tab makes ChatGPT not just a chatbot, but an ecosystem of purpose-built AI agents tailored to you. I have made one exclusive video on this, create your own AI chatbot. You can see I have created multiple GPTs based on themes, subjects, or interest areas. Below GPT, there is a new project folder tab. The new projects feature in ChatGPT introduces a game-changing way to manage long-term, structured work with AI. Instead of treating every chat like a one-off conversation, projects allow you to create dedicated workspaces where all your chats, files, prompts, and ideas stay together so you can build context over time. Whether you are developing a product, planning a campaign, researching a topic, or writing a book, projects turn ChatGPT into a true productivity companion, not just a prompt responder. Custom GPTs empower users to create personalized AI assistants that behave exactly the way they want. In the top section, you can see various versions of ChatGPT available for use. We are using ChatGPT 4.0 at the moment. Temporary chat in ChatGPT is designed for moments when you want a private, no strings attached interaction. Whether you are asking something sensitive, testing an idea, or working on a task that doesn't need long-term memory, this mode ensures nothing is stored or remembered.
Now, friend, let's understand what is prompt. In AI, a prompt is the instruction, question, or input text you give to an AI model to get a response. So it's basically how you communicate with the AI. That's the prompt.
So, in simple prompt, when we are giving the prompt like explain climate change to ChatGPT, so it is responding like climate change is the long term alteration of Earth's climate due to human activities and other factors. So in this, the answer is factual but limited, a single sentence definition. Words like long term alteration and other factors are broad, leaving room for confusion. No examples, no real world imagery, no tailoring for understanding. Reads more like a glossary entry than an explanation meant for learners. So, whereas in a prompt engineering, we can provide the prompt like you are a science teacher, explain climate change to 10th grade students using simple language, a real world analogy, and limited to three short paragraphs. So it will respond like, sure, think of Earth as being wrapped in a blanket of gases that keeps our planet warm. Climate change happens when this blanket gets thicker, trapping more heat and raising Earth's temperature. For 10th graders, imagine Earth is like a student wearing a thick sweater on a warm day. Eventually, they get too hot. So, in this, the words wrapped in a blanket of gases introduces a powerful analogy that makes science visual and relatable. The phrase student wearing a thick sweater on a warm day connects directly to the audience's daily life, making the explanation memorable. By breaking into short conversational sentences, the response feels like a teacher speaking to students, not like an encyclopedia. Even the opening sure signals a friendly, approachable teaching style. So there's a lot of difference between the response provided in the engineering elemental based prompt with the versus the simple prompt response.
Now we will see how prompt engineering is different from simple prompt. By definition, simple prompt is a basic instruction or a question given to AI without much detail, whereas in a prompt engineering, it's the art of designing clear, structured, and optimized prompts to get high quality, specific outputs. The style of simple prompt is short, vague, and often one liner, whereas in prompt engineering, the prompt is detailed, context rich, with rules, roles, and format specified. So now let's understand with the example. So in a simple prompt, somebody will write about AI. So whereas same simple prompt can be translated into advanced prompt like act as a tech generalist, write a 200-word article about the impact of AI in education using simple language and three real-world examples. So in simple prompt, the output quality will be generic, unpredictable, sometimes incomplete. Whereas in prompt engineering, the output quality will be much higher, specific, and well structured responses that are reliable and complete. The use case of simple prompt is casual chatting and quick answers, whereas in prompt engineering, it is widely used in business, research, content creation, coding, and problem solving.
This slide highlights the four essential elements of effective prompt design, showing how they help in shaping precise, useful, and tailored AI response. Element 1: Be clear. Clarity avoids vague answers. If your prompt is confusing, the AI output will also be confusing. Words like be clear emphasize that the simplest yet most important step is to remove ambiguity. A clear question leads to a focused, accurate response. Element second: Give context. Background details help the AI understand the situation. Without context, answers stay generic. Adding setting, audience, or purpose ensures relevance and personalization. Element number three: Define the role. Act as a lawyer. Assigning a role changes the tone, depth, and perspective of the response. For instance, a lawyer, teacher, or chef will explain the same concept differently, making the output more aligned with your needs. Element 4: Add rules. Explain in 100 words. Rules set boundaries for format, length, or style, ensuring the response fits the exact use case. Is especially powerful when you want concise summaries, structured reports, or controlled creativity.
Now let's see the technical framework behind prompt engineering. There are three technical key parameters that we can adjust in ChatGPT playground settings. That is, one is temperature, top P, and frequency penalty. Together, they control the creativity, diversity, repetition of AI responses. Temperature is the settings that decides whether AI plays it safe or gets creative. Low temperature gives you safe, predictable, and plain answers like mild food. A higher temperature adds spice, making responses more creative, surprising, and sometimes even unusual. In short, temperature is the dial that controls the flavor of AI output. Sampling decides how wide the AI's word choice can be. A lower top peak keeps the pool of options small, so the responses are more focused and safe. A higher top P opens up a large pool, making the answers more diverse and creative. In short, it's about choosing whether the AI plays within a narrow set of words or explore more possibilities. Frequency penalty is a parameter that controls how much ChatGPT avoids repeating the same words or phrases in its response. It reduces the chances of repeating words that have already been used. When you are in the playground or API, you get full control. You can play around with settings like temperature, top P, and frequency penalty to see how the AI reacts. But in the regular ChatGPT app like GPT-4 or GPT-5, you don't see those controls because OpenAI already tunes them in the background. They usually keep it balanced, clear enough to be useful, but diverse enough to stay interesting. Have playground version available, so we can also test in general production environment by specifying temperature and top P settings in the prompt itself. So in the first scenario that we have selected temperature and top P at zero point 0.2 level, which is the lowest setting of temperature and top P. So we have input the prompt in the chat GPT. So we'll see what is the response. Although it cannot literally change the internal settings in this chat, these parameters are only adjusted in Playground or via the API. What it can do here is simulate the style of output you would expect at that settings. So in this settings, you will see the response is more plain and robotic in nature, and it is less creative and engaging. Now we will try this prompt with another setting and we will see how the response of AI is. Now we have changed the temperature and top P settings at zero point 0.5 level. Now this is balanced settings with temperature zero point 0.5 and top P is at zero point 0.5. The AI is not too rigid, but it is also not overly creative either. You will see responses that are clear, focused, and still a bit flexible. Think of it like a middle ground, enough structure to say accurate, but enough openness to keep the answers natural and engaging. We have just seen how the AI responds at balanced mid-level setting, focused, clear, but still a bit flexible. Now let's push the dial to 1.0 for both temperature and top P. At this level, the AI is at its most creative and diverse. You will notice the answers become more imaginative, surprising, and sometimes even unpredictable. So here is where it all comes together. Different applications need different prompt settings. If you are doing customer support, you want low creativity so the AI stays accurate and consistent. But for marketing or creative writing, cranking up the temperature and top P helps generate fresh and imaginative ideas. In areas like legal documents or coding, we go the other way, low settings to keep output precise and reliable. Now let's try some prompts based on our learnings. By using various elements of prompts like clarity, context, and role defining, adding rules, we will see the response comparison between simple prompt and elemental based prompt, advanced prompt. Now in scenario 1, we have selected complex topic related with the science to explain quantum computing as a simple prompt. We have input the text in the chat GPT, so we will see the response that how it has responded. Now to have a better response from the AI, we have changed a simple prompt to elemental based prompt. If you see in the screen, we will write it as you are a science teacher explaining quantum computing to 10th grade students who are new to the topic. Keep the language simple, use a real life analogy, and limit your response to three short paragraphs. Now, the first response was technical and precise. It introduced key terms like qubit, superposition, and entanglement. But in the second response, element based response, it is simpler and analogy driven. It uses a spinning coin example to explain qubits, making it much easier for beginners to grasp. Instead of heavy jargon, it relies on everyday comparisons like solving a maze, which makes the concept more relatable. And it also given the three paragraph based response what So in scenario two, we'll be using a prompt like writing a marketing post about our new productivity app. So we'll see how the response of the AI will be in the simple prompt versus the advanced engineering prompt. So here we have given the simple prompt to the AI. Now in the elemental prompt, we'll write it as a act as a tech marketer, write a LinkedIn post introducing a new productivity app for remote teams. Keep the tone energetic and professional, limited to 150 words, and include a call to action at the end. So in this that you will seeing the response that you are specifying role as a tech marketer and you are adding a rule of limiting to 150 words and also specifying call to action context to the AI. So the response will be generated according to that. So in scenario 3, we'll take example of cooking recipe. So we compare the simple prompt versus the engineering elemental based prompt based on this scenario. So in simple prompt, we will share the prompt like give me a pasta recipe to ChatGPT. So we will see how the response will be based on this prompt. So just go through the screen that what kind of response that ChatGPT has generated based on this simple prompt. So you can see all the instructions that what ChatGPT has responded. Now there is an alternate option that is available, that how we can write this prompt in an alternate way based on the elements, various elements of prompt. Uh,
So in the elemental prompt, we will write it as you are a professional Italian chef. Share a pasta recipe that can be cooked in 20 minutes using only vegetarian ingredients and explain step by step with cooking tips. So you can go through on the screen what ChatGPT has responded with this elemental prompt. That yes, it can be clearly seen that there is a lot of difference between the response that has been shared based on this prompt versus the earlier simple prompt. So we will have a detailed comparison of the response between the simple prompt versus the elemental based prompt, so that we will explain it in detail.
so the first recipe feels like an everyday home cook approach, easy to follow, relaxed, and suitable for someone who just wants to make a quick pasta without thinking too much. And the second recipe takes on the persona of a professional Italian chef. The explanation is immersive, precise, and framed with the authority of culinary expert. So, in the recipe depth, prompt 1, that is garlic butter parmesan pasta. The steps are straightforward: cook pasta, make garlic butter sauce, toss, and finish with parmesan. It's minimalistic, beginner friendly, and focuses on flavor without complexity. In prompt 2, it is burst tomato and basil spaghetti, goes beyond cooking. It teaches why each step matters, like garlic color, pan size, emulsification, starch in pasta water. It feels like you are learning technique, not just following instructions. So, in terms of time and practicality, the first recipe doesn't commit to time. It's flexible but might take 25 to 30 minutes if done slowly. But in the second recipe is pretty structured, minute by minute. So all the place, sauce, emulsification, plating, ensuring it finishes in 20 minutes. This mirror how chefs work under time pressure. Diet and customization. The first recipe is not strictly vegetarian, depending on parmesan, but suggests optional add-ins like chicken or veggies. In the second recipe, where it is carefully vegetarian compliant, mentioning microbial rennet cheese alternatives and offering plant-based tweaks like nutritional yeast, olives, or pine nuts. It respects dietary boundaries more professionally. Outcome and experience. The first dish would taste buttery, cheesy, comforting, simple, classic with room for improvisation, perfect for a quick family meal. The second dish would taste balanced, fresh, bright with tomato basil, silky with emulsified sauce, a restaurant quality plate. It elevates the dining experience while still being accessible at home. So, in nutshell, prompt one response, that is simple prompt. It was simple, homey, flexible, a comfort recipe for everyday cooking. Whereas engineering elemental based prompt response was sophisticated, chef driven, technical. a guided masterclass on how to cook pasta the Italian way fast. This slide shows some of the best places to find free prompt libraries. Sites like Prompt Creator and All Prompts give you ready-made examples for almost any situation. Prompts Love and Prompts GPT are great for content and coding tasks, while GPT Bot offers prompts sorted by topics like design, marketing, or education. And if you like open source, the GitHub Awesome Prompts list has a huge collection made by the community. Let's explore some free prompts on the website promptcreators.com. So in this there are various free prompts available in almost all type of categories from artificial intelligence, business, career, entertainment, technical, education, every field that you can refer prompts here in this library. So here you will see prompts are designed and drafted according to elements like context, role, audience, task, and rule based. So free prompt libraries are like a ready-made toolbox. You don't have to start from the scratch. They save time, spark new ideas, and help you frame better instructions for AI. The more you explore and adapt them, the faster you will unlock creative, accurate, and professional results. Also act as a learning guide, showing you how different prompt styles change the response. You don't have to reinvent the wheel, just customize and build on proven examples. Over time, these libraries help you develop your own prompting skills and confidence. Think of them as a toolbox for innovation, always ready to boost your productivity.